All right, so our math workshop, Taylor, you weren't here. This is number 11. Make sure your math workshop is numbered number 11. All right, number 1 says, Amy is returning home after her vacation in Europe. Amy's suitcase is modeled by a rectangular prism that is 36 inches high, 12 inches long, and 12 inches wide. According to the airline, the maximum weight for any suitcase that can be carried onto an airplane is 10 kilograms. At the gift shop, Amy buys some picture frames for her friends. The price of each picture frame is 14 euros. Then what it's asking us, though, is which of the following values is closest to the volume in cubic feet of Amy's suitcase? So when I was reading this, guys, it gave us a lot of information. It told us she's coming home from Europe. It told us about her suitcase. It told us about the weight of the suitcase. It told us what she's buying in the gift shop. It told us how many frames. It told us the price of the frames that she bought in the gift shop. But we need to focus on what is it actually asking us about here. What is it asking us about in the question? Emily?
How much can it weigh?
Yeah, not how much can it weigh, but it's talking specifically about Amy's suitcase. All right, now it's asking about the volume. All right, now guys, we have not actually gotten to talk about volume a lot, so this is a good time for us to kind of mention it real quick in our math workshop. We're going to go over and we're going to learn and talk about volume in detail when we finish our Scantron testing. But for right now, guys, let's just mention what's going on here. All right, so volume. All right, so first of all, if we're talking about a suitcase, is a suitcase like a flat surface? No, when we're talking about a suitcase, we're talking about a three-dimensional object here. So like here would be here's my suitcase, okay? And then it has like a little handle on it. Okay, so there's my suitcase. All right, three-dimensional object, correct? All right, and this is called a rectangular prism because overall the whole shape is a rectangle that's 3D. When it's talking about the volume, all right, the volume isn't the weight. The volume is how much space is inside. So like if there's some reason she wanted to take a bunch of water and pour it inside that suitcase, how much would fit? All right, or how much space does she have to fit all of those clothes that she's packing for her trip to Europe? Okay, so the volume is the space inside that suitcase. All right, now we've been learning a lot about formulas. What formulas have we been learning, though? Okay. All the formulas that we've been learning, what are they talking about? Faith? All right, that's one of the formulas, but what is that formula about? Clear?
The area.
The area. All right, guys, the area is the space inside a flat object. The area is the space inside a flat object. So like if I wanted to know how much space was on the front of her suitcase, that would be area. If I want to know how much is inside the suitcase, now we're talking 3D, that's going to be volume. Do y'all see that difference? So area would be the flat, like the front of it, and then volume would be actually what's inside of it. Okay? Just like with area, volume has a formula. All right, and here's the cool thing about volume in the 6th grade. The only volume formula we need to know is for a shape like this suitcase. All right, and it's really, really easy. Okay, so first of all, I want to ask, does anyone remember what is the area for that flat surface? So if I just wanted the front of that suitcase, that rectangle, how do I find the area of that rectangle? How do I find the area of a rectangle? Faith?
Base times height or length times width.
Base times height or length times width. All right, guys, I want to talk about length times width right now, okay? So do y'all agree, if I'm talking about this rectangle, I can do length times width. Well, now I'm not just talking about the front of it, I'm talking about the whole inside of it, right? So my volume formula for that rectangular prism, it's really important that we're talking about rectangles here. The volume formula for that rectangular prism, we do need to know that it's a rectangle, which is where we get length times width. So again, length times width is because it's a rectangle, okay? And then we're going to also multiply that by the height. By the height. Okay? So we're going to do length times width times height. Okay. All right. So guys, in this problem, I'm sorry, I moved it up way too much. In this problem, does it tell me anywhere the length, width, and height of that suitcase? Where does it tell me the length, width, and height of that suitcase? Okay.
36 inches high, 12 inches low, and 12 inches long.
Right there on that line. All right. So guys, when it was asking me about the volume of the suitcase, we needed to know this and we needed to know that. All of the other information was extra. It was garbage. It was stuff we didn't need. It was there to distract us, okay? So let's find our volume. What's the length of that suitcase, Gabriella? How long is it? What is the length? 12, because it says 12 inches long. So I'll say 12. Times, what is the width of that suitcase, Kaylee?
12.
So it says 12 inches wide. And then what is the height of the suitcase, Cole? 36. Okay, so now guys, we got our handy dandy calculators. We can type that in. We don't have to do the long multiplication for all of that. When I type that in, what do I get? Faith? $5,184. And guys, now I know that obviously matches with E, but what measurement do you think is going to go with that? Emily? We need our inches. All right. So when we did volume, we put a 2 there. Because guys, when we were doing volume, those are like triangles, rectangles. They're all flat surfaces. That's two-dimensional. Well, guys, this now, when we're talking about the inside of that three-dimensional shape, it's three-dimensional. It's 3D. It's to the third. All right, also think about it. This is inches times inches times inches, which is inches to the third power. Okay, because we did, how many inches did we talk about? 3. Inches, inches, inches. So there are 3 inches. So it's that exponent 3. Okay. Which, another way of reading that is inches cubed. Oh, not inches. Oh, yeah, it isn't. It's fine. It's fine, y'all. It said cubic feet. I'm sorry, I misread it. We'll talk about that later, okay? So we're going to change this to cubic inches. Cubic inches. All right. Okay, let's look at number 2. Let's look at number 2. What do you notice about that problem when you start reading it? It's the same, right? This whole thing, Amy's returning home from a vacation in Europe. Amy's suitcase is modeled by the rectangular prism that is 36 inches high, 12 inches long, 12 inches wide. So guys, this is the same problem. Right? All the way down to when it's asking which of the following values is closest to the volume in cubic feet of Amy's suitcase. Okay? So now let's read the other half and see what it's actually wanting us to do on this problem. It says the total weight of Amy's suitcase and its contents is such that she can carry it on the plane. So that means, guys, she's going to be able to take her suitcase on the plane. Okay? The total weight of Amy's suitcase and its contents is such that she can carry it on the plane. And I know the wording sounds kind of weird there, but that's saying is the total weight of her suitcase and its contents, so and the stuff in it, is to where she can carry it on the plane. Okay? Given that Amy's suitcase and its contents weigh K kilograms, guys, we know they're using K because we're talking about kilograms, but what is that K called? What do we call a letter like that? What is that called, Emily? A variable. So that K is a variable. So K is representing kilograms, but what is K really holding the place for? How much the suitcase weighs. It's holding the place for a number. Do y'all agree with that? All right. So, guys, here's the question. So we're saying that suitcase weighs K. Do we know how much it actually weighs? No. All right, all we know is that she can carry it on the airplane. Now, what did it say about the suitcase for it to go on the airplane? What does it say? It has to weigh a certain amount. Raise your hand if you can read the sentence. What does it say in the sentence about the weight of that suitcase? Brandon?
According to the airline, the maximum weight for any suitcase that can fit on the plane is 10 kilograms.
The maximum weight for the suitcase is 10 kilograms. So guys, let's think about that. We know we're talking about my K, and we're comparing it to 10. All right? 10 is the maximum. Can K weigh 10?
Yes.
Yeah. So my suitcase can equal 10. Now, does it say that her suitcase weighs 10 kilograms? Okay. So, do we want it to just equal 10? No. Okay. All right. Can it equal 10? Yeah, so do I want to use these that don't have the equal bar? No, it can equal 10. It just doesn't want to be just equal to 10. All right, so now we're down to, is K less than or equal to 10? Or is K greater than or equal to 10? So for her to be able to carry it in the suitcase, if 10 is the maximum, 10 is the most her suitcase can weigh, do I want her suitcase, K, to be less than or equal to 10? Or do I want her suitcase, K, to be greater than or equal to 10? Michaela?
Less than or equal to.
Less than or equal to. We're choosing that A. Okay? So remember, guys, a lot of times, all right, Claire, I can wait. You guys stop. All right. A lot of times, guys, when y'all see maximum, we think big, so we want to choose greater. But maximum is the greatest, so everything else has to be less. All right? All right, guys, make sure that's number 11 in our binders. So make sure that's in the correct location in your binder. And we're going to look at our homework answers real quick. Okay, so, yep, okay, thank you. Make sure you take your calculator. Oh, thank you. All right, let me zoom that out some. That's a little bit too much out. All right, so guys, checking our answers on last night's homework. And you'll notice, guys, just to make it a little bit more clear, I went through and highlighted all of my bases I did in blue. Base, blue. And all I did for my heights, I did those in green. So that's kind of showing you what numbers I used and where I got them. If we're getting a different answer, you can look at it and see where yours are coming from. All right, remember right now you should be taking the time with your grading utensil, not just marking them wrong, but going ahead and fixing them, seeing what happened. So checking those rectangles for right now. Rectangle. Raise your hand if you need more time checking those or if you have a question about any of the rectangles. You will need more time. Cameron?
Number 6.
Mm-hmm. You didn't put those zeros? So those zeros we do need because there wasn't a decimal there. If the zeros are after the decimal, we can leave them off. But because those zeros make it 500, we did need to include those. So fill those back in. All right, we do want those zeros there. All right. No. Some people did the even just because it was some extra practice. Y'all were required to do the odd in here. Okay, y'all were required to do the odd in the regular math classes. But some people, I told them, I was like, if you're wanting to push yourself, my advanced classes were required to do all of it. It's some good practice. All right. I might try to do the odd before the test the even before the test on Friday to make sure I'm getting them all. All right, guys, I'm going to move it down to the triangles. Too much. There's a little bit of a lag between what's up there and what I'm seeing. It's hard to tell. All right, so there's our triangles. Let's zoom out a little bit more so we can get all of them on there. So checking out our triangles. Yes, Karen?
It's number
Number 11 is 410.4. Okay. Do we have any questions about our triangles? Any questions so far about any of those? Number 9 and number 10, I felt like were a little tricky. Number 9, 10, and 11, really. I saw a lot of people having trouble with the bases and the heights on those. Do we need to look at any of those? Number 11. So number 11, I saw a lot of people on number 11. They use 7.6 and 9. But guys, remember, what's our goal? When we're doing our base and our height, how do they have to meet? At a right angle. So guys, find that right angle. And that's why I chose 108 and 7.6. Because, Emily, do you see where those make the right angle there? So that's why those are the numbers we're wanting to use, where it makes that right angle. Okay. Okay, any other questions? I'm going to move it down so we can see those parallelograms at the bottom. Those two parallelograms. Saw some people this morning that came in to get theirs checked early that we're still using the trapezoid formula when we get to parallelograms. Remember, a trapezoid has to be making a triangle if I kept making them go on. Remember, these top and bottom are parallel and the sides are parallel. So since everything is parallel, it's got to be a parallelogram. All right, on the back. All right, these are more parallelograms. Okay, so finishing out checking those parallelograms. Parallelograms, questions about parallelograms? Raise your hand if you need more time checking your parallelograms. Okay. All right, parallelograms are good. Move it down a little bit. If I move it too much, just let me know. Those last two. Okay, so there's some of our trapezoids. Let's make sure we're checking those out. Checking out those trapezoids. Down some. Alright guys, there's the last few trapezoids. Okay. Alright, so make sure we're finishing checking those trapezoids out. Alright, guys, I know our trapezoids were some of the harder ones, and you'll notice I still kept my blue and green going, but this time there were two blue lines because trapezoids have two bases. And if you'll look, every time those two blue lines run parallel to each other. Okay, do we have any questions about this problem? All right, our notes for today. All right, guys, this is like one of my favorites. I think it's kind of fun. All right, what we're doing today, I think it's kind of fun. You might agree, but I think it's kind of cool. Make sure, guys, as you're getting your notes, so those are coming around. As you're getting your notes, if we can please number those. Number 12. It was only the odd, but if you did it even, that's fine. Number 12. Okay, so please make sure you number it number 12. Go ahead and make sure you put your name on it. So if it's left in a classroom, or like my classroom, I'll know it's yours. It doesn't just end up in the trash or lost forever, because no one knows who it belongs to. All right. So what we're doing today is a little bit different. Instead of just being given a shape, we're going to be given a shape with some of the shape shaded, some of the shape is not shaded. So like here you'll notice we have a big rectangle, and then inside there's an empty spot that's in the shape of another rectangle. Right? Guys, it's not asking me for the shape of the two different figures. It's not asking me for the area of the two different figures. It's asking me just to find the shaded region. So guys, when I find the area, I just want this outside piece. I just want this outside piece. All right? Now, the problem with that, guys, is when we're finding the area, like if I find the area of this big rectangle, what you're doing is you're telling me all the space inside the entire rectangle. Am I wanting all the space inside the entire rectangle? No. All right? We're wanting to take out, pay attention to the words I'm using, we're wanting to take out this rectangle on the inside, right? I'm wanting to take that out. Guys, what operation lets me take something out? What lets me take something away? Cameron? Subtraction. So when we think of a shaded area, we should also be knowing, hey, that means I'm going to have to subtract. And I should be doing that in pen so y'all can see it. We're going to have to subtract. All right, and those kind of go together. Shaded, subtract. So shaded, subtract. All right.
What's on the outside numbers, and then we find out what's on the inside, subtract the inside of the outside.
So that's exactly what we're doing. We're finding the outside area, or the outside shape. We're going to find the area of the outside shape, and we're going to subtract the area of the inside shape. All right, and I'm actually going to put a little S in parentheses there, because if you look down at number 3, it has more than one shape inside of it. So sometimes you're going to be subtracting more than one thing. Okay. All right, so if we're doing shaded, we're subtracting. What we're subtracting is our outside shape minus the inside shape. You okay with that? All right, so guys, when I'm doing my notes are going to be very clear. I'm going to do a lot of writing. What I'm going to be looking for on your homework is, again, I want to see what formulas you're using, what numbers you're using, and then those answers, all right? On our notes, though, we're going to add a little bit more information. So first of all, guys, let's talk about the outside shape. And because these are my notes and I want for everyone who looks at them to know what I'm talking about, I'm going to write there that I'm talking about the outside shape for right now. All right, the outside shape is also going to be the bigger shape. All right, because if it's going around everything, it's got to be the big shape. Okay, so make sure you write that down. If I write it on my paper, guys, you need to be writing it on yours. We're setting up our work the same. So when we look back at it, we know exactly what's going on. Okay? All right, what is the shape that's on the outside? What shape is that? Raise your hand if you can tell me. What shape is that, Emily? It's a rectangle. We all remember that's a rectangle, right? Okay. So obviously on this outside, that's a rectangle. What is my formula for the area of a rectangle? What is the formula for that? Faith?
Base times height times width.
A equals base times height. Guys, make sure you're putting that A equals, because as we saw in our math workshop today, we're not always going to be talking about area. So we've got to make sure that we mention area when we're using that formula. All right? So for that outside rectangle, what is the base of that outside rectangle? Emily? 12. So if we use 12 as the base, what is the height of that rectangle? Emily? 5. All right. Now, guys, could we have used 5 as the base and 12 as the height? Yes, those could have been flip-flopped. All right. Now, we know what 12 times 5 is. Hopefully, 12 times 5 is? 60. 60 what?
60 centimeters squared
centimeters squared. So that's the area of the outside shape. So now, guys, I need to do the area of the inside shape. Okay, so I'm going to write inside, which is my small shape. All right. Guys, I would like on your homework for you to show, hey, this is what's on the outside, this is what's on the inside. So I want you to keep that labeled like we're labeling it. All right, what shape is inside? What shape is it that's inside? Ava, what shape is that inside? It's a rectangle. So we have a rectangle inside of the other rectangle. Okay, that's fine. So what is my formula for a rectangle? Still going to be, it's not going to change. What's my formula for a rectangle, Maya? A equals base times height. Okay, so for the little rectangle, what is the base of the little rectangle, Lyric? 8. So the inside base is 8. And if I choose 8 as the base, what does my height of that rectangle have to be, Gabriella? 3. Okay, so now 8 times 3, that again should be something we can do in our head. If you need to use the calculator just to check, that's fine. What do we get there, Caleb? 24 what? Centimeters squared. And guys, I'm writing those measurements just to keep reinforcing every time we put an area, we want the measurement. All right, so now what am I doing with these two areas? What am I doing with my two areas? Blake? Subtracting them. I'm going to do 60 minus 24. And 60 minus 24, what does that give me, Cameron? 36 centimeters squared. Because it's still talking about the area, right? But now instead of being the area of the inside of an entire rectangle, that 36 centimeters squared is just this gray part that's shaded in. Isn't that kind of cool? We're able to find just that outside part. Okay. All right. Guys, we're going to skip over number 2 for right now. We're going to look at number 3. We're going to look at number 3. All right. While number 3 looks harder, it's actually not as hard. It's actually not as tricky, okay? All right, so we're going to do number 3 first. For number 3, what is my outside shape? So that's where we got to start. Outside. Outside. What is my outside shape on number 3? What is that outside shape? Brandon? It's a trapezoid. Guys, remember, it's a trapezoid because while these outside lines are parallel, are my top and bottom line parallel? No. And in fact, if I made that top and bottom continue on, what's it eventually going to form?
Triangle.
It's going to make a triangle. And guys, yesterday what we talked about, because some people were still having trouble with trapezoids and parallelograms, is if it will make a triangle eventually, then it is a trapezoid, right? Triangle and trapezoid kind of thing match together. All right. Outside. So for that trapezoid, what is the area formula? What is the area formula for a trapezoid? Taylor? Excellent. A equals base 1 plus base 2 times the height divided by 2. Okay. What are my 2 bases for that trapezoid? What are the 2 bases? Kate?
9 centimeters squared, 7 centimeters.
9 centimeters and 7 centimeters. We don't put the squared until we actually get the area. Okay, so that's 9 centimeters and 7 centimeters. We see how those are going the same direction, right? Okay. So that means in my parentheses, I'm going to have 9 plus 7 or 7 plus 9, either way. All right. And then I'm going to go ahead and put my divided by 2 so I don't forget about it. What is the height of that trapezoid that's on the outside? What is the height of that trapezoid? Kaylee? All right, so 9 was one of the bases, right? We use this and this as my base. So what tells me how far apart those 2 pink lines are?
8 centimeters.
The 8. Very good. Okay. All right. So now, guys, it's just a matter of either typing it into our calculator or doing the math out loud. I want to show you something because I've noticed some people, when they're typing stuff in their calculator, are kind of doing it the longer way. So, guys, when I'm going to do 7 plus 9. 7 plus 9. And then I'm going to go ahead and put equals. So 7 plus 9 is 16. Is 16. Now it's kind of hard to see. I'll move it over. All right, so 7 plus 9 is 16. All right. Then, guys, the next thing we're going to do is divide by 2, right? So I'm just automatically going to put divided by 2. And y'all see where it says A and S? What that means is the last answer. What was the last answer that my calculator gave me? 16. So now that's doing 16 divided by 2 for me. And then I'm going to put equals. All right, now after dividing by 2, what do I still have to do? Times it by 8. So guys, again, I can do times. Now guys, this time, what was my answer that I just got? 8. So when I hit times, what is that A and S talking about? 8, because that was the last answer my calculator gave me. So I do times 8, which equals 64 centimeters squared. All right, some of us are like getting an answer and then typing the answer in and putting times 8 again. Guys, we can save ourselves some time and some mistyping, because sometimes when we're typing a number, we might hit the wrong thing by just using that answer. It'll save us some errors. All right, so guys, inside this time, how many shapes do I have? 2. So I'm just going to number them. I'm going to let that be shape 1 and let this sheet be shape 2. Guys, if having those numbers in there is too much for you, you don't have to. I'm sorry, Kate?
Well, you have to change the weight, like the base 1 and base 2, but it's like a square and rectangle when they're inside.
All right, well, no. Mm-mm. And this actually isn't a square, because for it to be a square, they both have to be 2 and 2. All right, and here's the cool thing, guys. A square is just a special rectangle, so a square is still just base times height. Okay, a square is still just base times height. All right, so inside, let's work on shape 1. So I'm going to say shape 1 inside. All right, what shape is shape 1? What shape is shape 1? Michaela? This one? It's a rectangle. So what's my formula for a rectangle, Michaela?
A equals base times height.
A equals base times height. All right, on that first rectangle, what's my base? Annabella? Okay, 1. And so what's my height going to be there? 3. Okay. So I got 1, because that's that number right there. And I know it's hard to see on the projector and on the screen, but it's easier to see on your paper. All right, and then we have 3. So 1 times 3 is 3 centimeters squared. All right, is that the only shape I have inside?
No.
No. So now we're going to do inside,
That's what I was talking about.
and we're going to do the second one, inside 2. All right.
If it was on the inside and it was a different shape from the outside, then you have to change the...
Yeah, you have to use the formula for what shape it is. Well, yeah, that's a good question. I see what he's saying. Because the first 2 had the same shape on both, so we use the same formula. Here you use the formula for the shape that you're doing. So this second shape, what shape is that? It's actually a rectangle. I know it looks like a square, but do you see how that says 2 and then 3? So guys, remember, you can't just count on the way something looks. All right, you've got to look at those numbers there. So this is going to be a rectangle, actually. And what's my formula for a rectangle? Emily? A equals base times height. Now, guys, here's the good thing. Even if it was a square, we could still use base times height. They would just both be the same number. Okay. All right. So what is my base for that rectangle going to be? What is my base? Ava? 3. All right. And then what is the height going to be, Ava? 2. So I get 3 times 2, which is 6 centimeters squared. All right, so I have outside, inside, inside. Remember, what's our goal? To take the outside and subtract the inside. So, guys, I'm going to take 64. That's my outside. Minus 3. Minus 6. So I'm just doing 64 minus 3 minus 6. Some people today have said they wanted to add the inside together because they're both the inside. If you want to add and then subtract, you can. Me, since we're subtracting it, I'm just going to do, and in my calculator, I can do 64 minus 3 minus 6. Type it in just like that, and it's going to give me 55. Now, Kate, you said you added yours and then subtracted. Did you still get 55 centimeters squared? Excellent. So either way that you do it, we should get the same answer as long as we calculate correctly. All right, let's go back and look at 2 now. Let's go back and look at 2. All right, and 2 really isn't that bad. It's just we got to use our brain a little bit. All right, on the outside, what shape is that on the outside? What shape do I have on the outside? Ella? A triangle. Cannon, what is my area formula for a triangle? Excellent job. A equals base times height divided by 2. Now, when I'm looking at the base of that triangle, what do you notice?
The bottom one, there's like 3 arrows.
There's like 3 different numbers, right? So we have this piece of the base is 5, this piece is 4, and this piece is 5. So what could I do if I wanted to know the entire length of the bottom? What could I do to that if I wanted to know the entire length of the bottom? Taylor? Add them up. So 5 plus 5 is 10 plus 4 gives me 14 centimeters. So the whole thing is 14. So when I'm doing this formula for base times height, my base is actually 14. Do y'all agree with that? Do y'all see where I got 14 from?
Yeah.
Okay, there you go. That's what made it hard. Okay. So now, guys, we need to know how tall the triangle is. How tall is this triangle? Gabriella?
10 centimeters.
Excellent job. So Gabriella said it's 10. All right? And I love how she looked over here. Some people in my last class wanted to say 6. Now, guys, if I wanted to know how tall you were, would I just measure you to your belly button? No, that's basically what's happening here. We're going to the triangle's belly button. We don't want to know how tall it is halfway. We want to know the whole thing. So Gabriella looked over here and said, hey, this goes from the bottom all the way to the top. All right? So that's going to be the height is 10. Excellent job. Divided by 2. Okay. So 14 times 10, that's 140. Do that in our head pretty easily. And 140 divided by 2 is? 70. Excellent job, guys. 70 centimeters squared. Oh, sorry, that's not my answer. Didn't mean to start circling that. All right, so now we got to do the inside. Inside. All right, Lyric, what shape is that inside? A trapezoid. Annabella, what's my formula for a trapezoid?
No. A equals B1 plus B2.
A equals B1 plus B2.
Times height divided by 2.
Times the height divided by 2. Very good. All right, so now what are my bases on that trapezoid? What are my bases? Raise your hand, Kate. 6. So there's 6 on the top. And there's 4 on the bottom going across. So do y'all see those are going the same direction? So those are my bases. All right, so we're going to have 6 plus 4. What is the height of that trapezoid? Michaela? 6. All right, and I went ahead and wrote divided by 2 under there so I didn't forget about it. Okay, let's do this one. This one we can probably do in our head too because what's 6 plus 4? 10 divided by 2? 5. Remember dividing, not subtracting. So 6 plus 4 is 10, divided by 2 is 5, and then 5 times 6 is? 30 centimeters squared. So now, guys, now we're ready to do the last part, which is just take my outside, subtract the inside. So 70 minus 30, what do we get as our answer here? 40 centimeters squared. All right, so if I put all of those little triangles that were made that are gray, if I put those together, it would give me 40 centimeters squared. Okay. All right, if you'll flip it over, guys, on the back. All right, your back is the homework. It's just 4 problems. Your back is the homework. It's just 4 problems. Guys, look at number 4 with me real quick. What is my outside shape? A triangle. What is my inside shape? A triangle. Yes. All right. So, guys, we have a big triangle and we have a little triangle. Guys, there's another way to do this if you can think of it. I'd love to hear your input tomorrow. But I do want to point out it tells me this whole thing is 8. Do y'all see that? What do these two marks mean? That means they're equal to each other. So guys, if these two marks are equal to each other and the whole thing is 8 centimeters, what do those two lengths have to be? Michaela? 4. Because the only number that I can do 4 and 4, where I can do the same thing, is, again, give me 8 is 4. Could I do 5 and 3? No, because 5 and 3 aren't equal. 5 and 3 give me 8, but are they equal? No, so it has to be 4 and 4 there. So I wanted to just mention that. All right, guys, your homework is to finish that. Are there any questions?
Can we start?
Mm-hmm.